Good afternoon and welcome to the Moscow Telecommunication Seminar. Our today's speaker is Aleksey Kureev. Aleksey Kureev is a researcher in Wireless Networks Lab at the Institute for Information Transmission Problems, a researcher at the Laboratory of Telecommunication Systems at the Higher School of Economics, and PhD student at the Moscow Institute of Physics and Technologies. He has authored more than 10 articles at the international conferences and peer-reviewed journals. Currently, he is a voting member of IEEE 2.11 working group, which standardizes Wi-Fi technology. Today, he will share with us the new direction of Wi-Fi standardization, which is devoted to wireless sensing. Alexei, the floor is yours.
Thank you, Vyacheslav. Good afternoon, everybody. And today we are going to discuss Wi-Fi sensing, a new technology to sense that allows the Wi-Fi device to sense the environment. And we go through the possible applications of this technology, the challenges which are now faced by Wi-Fi standard, and the current status of this idea on this direction. Let's start. At first, let me describe what is Wi-Fi sensing. This technology allows the Wi-Fi device to receive information about the environment using the information from Wi-Fi frames that are transmitted by this device or other device in the environment. And this information about the environment can be used by this Wi-Fi device to detect some motions, to understand the behavior of people around this device, and so on. For example, here we have one device, which is this orange one smartphone and Wi-Fi access point, and orange smartphone transmits signal. And since we are not working in vacuum, we stand in some environment with multipath propagation. Access point receives the direct signal and some reflected signal from walls and from moving person. And using this information about the channel, about the environment around it, this access point can understand the movement of this person and then do some things related to applications. And the all current my talk will be about how existing Wi-Fi technology allows this device, Wi-Fi device, to sense the environment, and how the future Wi-Fi will help Wi-Fi devices to sense the environment better. Quick outline. First, we will go through applications of Wi-Fi sensing and see some business opportunities, research opportunities for this technology, and you will see some several non-trivial applications, and some of them can be in opposite trivial. Then we will go to the development process of the new standards, new amendment to Wi-Fi, which is called 802.11bf. And understand how this feature like Wi-Fi sensing can be put in standard. Then we will go through channel measurement procedure and we will understand which types of signal and which types of information from the current and future Wi-Fi frames, Wi-Fi signals can be used for Wi-Fi sensing. Then we will go to performance evaluation and understand which metrics can be used to evaluate the accuracy of Wi-Fi sensing. And then we will go through requirements to existing Wi-Fi networks and the future Wi-Fi networks to make Wi-Fi sensing, and go through the gaps in existing Wi-Fi and how a future Wi-Fi will close these gaps and fill it. So at first, let's go to applications. And one quick question, but not question note. If you have any question, you can ask in chat or just write it down currently, or for example, you can ask after my presentation. So let's start. Applications. The first application is home monitoring. It's probably the most obvious application. And the idea is as follows. For example, you have a smart home, and this smart home is equipped with several Wi-Fi sensing enabled access points. Moreover, you have some smart devices like lamp, TV, some kitchen furniture that can be equipped with Wi-Fi adapters too. These devices periodically or in some other way transmit some data to the access point, and using this information, Wi-Fi access point can sense the environment. What happens? For example, you have a robber inside your house, and Wi-Fi access points, they feel and sense the environment and see that there is some changes in this environment, and they can send alarm message to your smartphone, and using this alarm message you can understand that there is some problem inside your house, and it's not a moving cat, it's not a moving dog, it's a real person, and you understand that there shouldn't be any person now currently in this house, in your house, and you need to return to your home or call the police and so on. And requirement for this technology for Wi-Fi sensing to achieve and to make this application possible is the detection of large-scale motion, approximately 1 meter. Moreover, this access point should differentiate human motion and pet motion, or some mechanical motions. For example, if you have a smart vacuum cleaner which walking around your home, and of course it transmits some Wi-Fi signal and change the environment too. And moreover, you need to localize the motion into a room or an area in the house or building that you have. Then another application is energy management. For example, you want to save the energy in your house. You want to switch on or off your lamps or other furniture inside your house. Wi-Fi sensing enabled access points can do this task. So they detect large scale motion too, and depending on your movement inside your house, they can switch on or switch off some devices to save the energy and make your pay less for your house. Another case is elder care. For example, you have your grandpa, which is alone at home, and you need to understand what happens to him. For example, here, again, you have this Wi-Fi sensing access point, and they can detect the fall of the elder. And then they can send an alarm message to your smartphone, and you need to, after that, you can do something. You can return back to your home or call something to take care about your grandpa. And here you need not only to detect the movement, you need to detect the specific large-scale motion, for example, fall in the large area. And moreover, you need to localize this motion too. And here in all these examples, I should notice that we in this case, we mean the passive localization. So there are no any special devices which are put on your elder or to your on your grandpa. So there are only devices inside your house, like smart devices and Wi-Fi access points, and only using these devices without any transmission from your grandpa, you need to receive the information about the fall and understand what happens inside your house. Another case is wake on approach or lock on the way. For example, you have your smartphone or your laptop, and you come to your laptop. When you come to your laptop, you can make some special gesture, and using this, your device without any camera can detect this movement, understand this, and unlock your laptop, and you can work with it. This is wake on approach. Another thing is lock on the way. For example, you're working with your laptop and you want to go out, and your laptop is automatically go to power save mode or locks or is locked. And this is more specific case, it needs more accurate measurement of the environment. And here you need to detect especially the proximity of human to a specific device. And moreover, it needs to detect, sometimes it depends on the application, some special gestures to unlock or lock your device. And more specific is gesture recognition. I think everybody knows what is Kinect, and Wi-Fi can replace the Kinect and work as a Kinect too. For example, you can do some small scale gesture recognition or some large scale body pose recognition. This opens up many business opportunities from some teleconference and some digitalizing your person, make a digital avatar of your personality, or some game scenarios when you want to play or dance, and you make you want to have your digital person which copies your movement and works in virtual reality or and so on. And here you need to detect a small scale finger or hand gestures if we consider small scale gesture recognition or large scale body poses. And this is a very difficult task, but it can be done and it is possible. Okay, and another case is biometric. For example, you have a some smart device which stays in your home, and you are moving around your house, and this device using Wi-Fi frames and Wi-Fi signals, it measures the environment and understand your biometric KPIs, or not KPIs, some biometric measurements, your heartbeat or your breath, so how it is it healthy or not. And this can be done using Wi-Fi too. Here we need to have extremely high resolution detection of body movement, such as chest movement while breathing or your heartbeat. And it can be possible too. There is some papers which uses Wi-Fi networks and Wi-Fi access points for this case. And I will provide some papers for you if you want to deep dive into these ideas and read more. For example, this one, which is on the bottom of this slide. Another case is very popular now, I guess, sneeze sensing. It's very relevant due to Corona. And the idea is as follows. You can use the overall Wi-Fi architecture in your house or in office to understand the sneezing and how often or how rare the sneeze happens inside the building. And okay, if you have and if Wi-Fi devices can detect many sneezes, you can make some alarm, you can make some decisions about the overall epidemiologic situation inside your house, and understand what to do. Probably you need to have a quarantine or so on. And here, as I say, sneezes plays a key role in transferring respiratory diseases such as COVID, and it's popular too, and Wi-Fi can be used for this case too. And here you need not only to detect the body movement, for this scenario, you need to detect also the droplets detection. You need to detect the droplets. And moreover, you need to detect the volume of these droplets. And this is a great task, but there are some papers which are related to this topic, and this is possible too. Okay, and here in the following lecture, in this this following talk, we will not cover the ways to detect some specific motions. We will not describe some machine learning approach or some signal processing tasks, so how we can measure some Doppler frequencies on the channel responses or understand some rapid measurements, rapid changes in the environment, how it can be used for detect the movement. So it's the separate topic which are extremely huge. And each of these scenario can be used for separate talk for 1 hour long and so on. So here we are going to tell, here I'm going to tell you only about the Wi-Fi technology and how Wi-Fi, how signals from Wi-Fi can help to measure the environment, and how these measures can be used for detection of some movement. It's a separate task. So let's go. As I say, this is a special, Wi-Fi sensing is a special technology. And this technology can be done on existing Wi-Fi devices, or it can be used in future Wi-Fi devices. And if we go through the history of this technology is quite young. And first, in 2019, there was a first draft of this technology, which was proposed by Wireless Broadband Alliance. So they introduced this technology and introduced some applications of this technology and introduce how the existing Wi-Fi can be used to sense the environment. And after that, all the ideas which was provided by Wireless Broadband Alliance, they are collected and go to IEEE Standardization Committee, to 802.11 802.11, and 802.11 is going to provide a new amendment aimed on Wi-Fi sensing, which is called 802.11bf. And here I will describe some topics which are covered in the Wireless Broadband Alliance, and how they are evolved, and how they will be put and how they will be work in 802.11bf. If we consider 802.11bf, so this amendment is quite new and young too, and the PAR approved in September 2020. This PAR contains some requirements to this amendment, so and the aims of this amendment. And according to the plan, in September 2024, we will have a new amendment, so there should be a new release, and we will go through it, understand how it works. And as you see, there are 4 years. They need 4 years to develop this amendment, and we are only at the beginning. But anyway, some of features of Wi-Fi sensing can be done even currently. And the main idea of this amendment is to concentrate of some procedures that allows Wi-Fi sensing or WLAN sensing applications to reliably and efficiently obtain measurement results, but not the ways to detect movements and so on. So this amendment concentrates only on frames and how the frames and signal should be inside the how signals and frame exchange should be organized in future Wi-Fi. So environment measure procedure. As I say, some of use cases of Wi-Fi sensing can be done even now. And at first, let's go through some terminology and understand so the common language, and formulate the common language with you and me to understand how Wi-Fi sensing works. We have a Wi-Fi sensing enabled receiver that receives some information from other devices or from itself and measures the channel and understands how the environment works. We have the illuminator device. So why illuminator? So it's some related to the optics. You have sun illuminates, and because of the sun, you can see the surrounding, and illuminator device transmits Wi-Fi signals, and it transmits illumination signal, which helps Wi-Fi sensing enabled receiver to illuminate the environment, and Wi-Fi sensing enabled receiver receives the echo signal. So the combination of the direct signal from illuminator device and some reflections from the environment and from some specific object that we want to sense. And what information we can use for Wi-Fi sensing. As I say, there are lots of work, lots of research that are related to Wi-Fi sensing now. And some of the applications are based on the existing Wi-Fi. And that's why we can say that some of use cases can be used now. And what features and what things of Wi-Fi technology can be used? At first is RSSI, Receive Signal Strength Indicator. So this information can be obtained by everybody if you switch on your Wi-Fi module inside your smartphone and download some application like Wi-Fi. I forgot the name of this application. So some application that sends the Wi-Fi networks inside. Let me check. Oh, Wi-Fi Analyzer. Yeah. You can see the information about the access points around you, and you can measure the received signal strength indicator of all signals of all the Wi-Fi access points around you. And using this information, you can understand how good your signal from the neighboring access points or not. And of course, if you just switch on your Wi-Fi module, you can see just these icons, and moreover, you can measure them using some specific software. And moreover, using this using this parameter RSSI, you can measure the movement or some changes in the environment, and according to that, you can understand what happens inside your building or house and so on. And for some not so accurate measurement, RSSI is okay. It can be used even right now. Another case is fine-grained channel state information. So channel state information is the information which can be obtained from each Wi-Fi frame. And this information is contained in special field inside the preamble of each frame. And moreover, since Wi-Fi and current modern Wi-Fi use OFDM, or orthogonal frequency division multiplexing for data transmission, you can obtain information from each subcarrier that are used for signal transmission. And here is, so if RSSI is only a value, a single value for single antenna or for multiple antennas, so depending on scenario, which are used for measuring the quality, the overall quality of the signal. This is more accurate and is more precise metrics, and moreover, it can be obtained by every Wi-Fi frame. But it's very difficult for commercial users to obtain it. So you need to modify some Wi-Fi drivers or use some specific equipment or modify your Wi-Fi access points to do that. But anyway, it is possible. And each information from each subcarrier, from each antenna, is a complex number which understands how the amplitude of the signal changes and the phase of the signal changes due to propagation in the environment. And very quick example of that. For example, we have on the left signal, so some samples of channel state information which obtained in a static environment without any movement. And on the right, you can see that there are some changes, and you understand that this channel state information changes, and you see that it varies quite vastly, and you can use this information for your measurements, procedures, and so on. Another case, which is more relevant from my side, from my point of view, to 802.11ad and 802.11ay sensors, which works in 60 gigahertz band, is mid-grained beam attributes, or for example, as we know, in these amendments, in these standards, Wi-Fi uses beam steering and beam sweeping algorithms to understand the environment and to not understand the environment, but to organize the beam forming procedure and to organize the MIMO transmission. And if in this case, the access point use beam sweeping and then chooses the optimal beam that maximizes the received signal strength indicator or signal to noise ratio on the device, and the device uses the same thing to make a beam forming and MIMO transmission to the access point. And this beam sweeping procedure can be used to measure the environment too, and this can be helpful too, and it can be obtained even right now using commercial 60 gigahertz Wi-Fi routers. Here, if in previous example, we cover information, channel state information, which can be obtained from several subcarriers of OFDM signal. Here we have several sector index, which are related to several beams during the beam sweeping procedure. And for each beam and each packet index, we have a SINR that can be measured and can be used for measurement procedure. And least but not the last is the information mid-grained from the explicit feedback procedure in common Wi-Fi's like 802.11n, 802.11ax, AC, and further. We use the explicit feedback procedure to organize the MIMO transmission. And in this case, the access point sends some sounding frames to the device. Device feedbacks from sounding to the access point and send not the actual channel state information matrix, but some compressed information which are obtained using this TSI matrix, actual TSI matrix, which are given, which are obtained by sounding frames. And then access point transmits beamforming frames. And here, the first two steps of this procedure can be used for Wi-Fi sensing, even right now. And how can be organized? How this Wi-Fi sensing procedure can be organized? At first, the first idea is monostatic mode. And in this mode, only one device, for example, this Wi-Fi access point, can be used as a Wi-Fi sensing enabled receiver, and it also acts as an illuminator device since it has several antennas. It can transmit for a signal from one antenna to another antenna, and since the signal reflects from the environment, it understands the environment, measure it, and do some Wi-Fi sensing stuff. Another case is B-static. If you have one static device which are illuminator, and another device which is access point, which are Wi-Fi sensing enabled. And of course, here you can measure the environment too and understand what happens. And multi-static, if you have several devices, and it's quite difficult from my point of view and from the standards committee point of view to organize this procedure. But anyway, it exists. And it can be used for a Wi-Fi sensing procedure. And of course, here several devices transmit some data, transmit some signal, and it can be used for Wi-Fi sensing. From the point of view of several colleagues, my colleagues in standard committee, so especially from Intel, as far as I remember. So they declare that monostatic mode is the most opportunistic for Wi-Fi sensing because it allows to implement the high complexity of sensor device, And moreover, you do not incur some devices around you, some stations, which in Wi-Fi terminology. And moreover, for this case, you do not even know, you do not even need to implement the 802.11bf in other devices. You can use only only your own Wi-Fi access point from Cisco, Huawei, or other companies. They can implement their own stuff, and they can work only in monostatic mode, and it will be okay. So, and that's why we can say that probably it's a winner now, but as I say, the 802.11bf is on the beginning of the development, and actually there is no the common meaning of the whole sensing procedure, the common idea how it works. And now the standard committee just discuss which ideas are the most possible and so on. Moreover, we can consider that there are several modes of this sensing, so how it can be organized. At first, this passive, and there are no any amendments to 802.11bf. So just devices transmit data frames, and Wi-Fi sensing receiver receives it and measures the environment. Another case is invoked where Wi-Fi receiver transmits some data, it receives some illumination signals, and using these signals, they can measure the environment. But actually, these formats are not defined yet in 802.11bf. So how the frame will be, so it's not a clear understanding now, and they are under development. Another case is involved with reports, as for example, like explicit sounding feedback. So you can measure and you can receive some reports. And here, there are no any concerns about this measuring procedure and what the information can be used. Do we need to use the actual explicit feedback procedure, or we need to modify it somehow, or use other measurements which are same, or there are no clear understanding. And the trigger pushed, for example, you have an eliminated device that transmit beacon frames or something like that, and Wi-Fi sensing receiver receive it and obtain information about it. Another case for threshold-based sensing measurement, which are defined as optional case, and they are related to this case when you have a reporting phase and you need to report information about the environment to the access point. The device access point sensing device transmit NDP, NDPA, NDP. According to NDP, device around measures the environment, and during the measurement phase, they save the information about the environment. And then the access point transmits the feedback request, and then if the environment changes significantly, the devices, illuminators can, but here there are no any illuminators here, but they are reporting devices. They can transmit some feedback metrics or the differences from the current measurement to the access point to save the resources. For example, here for orange device, criteria are met, and for purple one, criteria are not met. And here we transmit ACK frame, orange station, and this access point transmits feedback request. And as a result, orange frame sends NDP or something else to transmit this compressed diff from the CSI measurement, and access point can reconstruct the CSI. And it's optional. It's very optional. It can be done in 802.11bf. If we consider some use cases and frequency bands for Wi-Fi sensing, all bands can be used, all possible bands and all possible bandwidths. There are no any restrictions. And moreover, you can use all types of Wi-Fi network and topologies. And performance of Wi-Fi sensing, of course, depends on the interference. As you know, interference is a silent killer of Wi-Fi. And if we have an eliminator device, an interfering device, Wi-Fi sensing receiver cannot sense because it gets some interference from the interfering device. Moreover, coverage and signal strength is very important too. If the signal is too weak, Wi-Fi sensing receiver cannot sense anything too. And the channel bandwidth too. The more bandwidth you use, the more wider bandwidth you use, the better is illumination. And frequency band. For small scale gesture recognition, preferable is 60 gigahertz bands, and for large scale body recognition is 5 gigahertz bands. For some specific case, which not related to some accuracy, but some specific action, like enemy detection inside your house or human fall, you can use even 2.4 gigahertz band. And the number of antenna, of course, is very important too. The more antenna you have, the more sensor you have. And the access point with the many antennas is the most suitable for Wi-Fi sensing. So this is the list of these parameters which are discussed now in standard committee to be included in some Wi-Fi sensing discovery procedure to understand the capabilities of devices around to sense the environment. But they are not fixed. If we want to measure some reliability of Wi-Fi sensing, of course, there are some measures related to the probability. The probability of hits. So, for example, if we have the robber inside your house and the probability of hits that our Wi-Fi access point detects this robber and send the alarm message to your to the owner of the house. The probability of misses is the probability of no detection of the motion of interest when it occurs. So, for example, if we have a robber, but we detect the kitten. Or the other case is the probability of false alarms. It's less important, but anyway, we need to measure it. So if we have the kitten, but we detect a robber. So we send some alarm messages, but it's a kitten. And the probability of correct rejections. Here we can the probability of correct detection of no motion of interest when it's either no motion or not the event of interest, for example. So if we do not understand that it's a kitten, but anyway we need to sense the robber, and there are no any importance for us do we detect kitten or not. So let's go down. Let's go further and go through the technology requirements. So we are close to the end of my presentation, and here we can say that here in this section I want to understand and describe to you what parts of Wi-Fi signal can be used, or Wi-Fi frames, for sensing procedure. Of course, if we consider legacy of DM preamble, which introduced in 802.11a in legacy Wi-Fi, you can use LSTF parts of which are used for synchronization, automatic gain control over the receiver, and the power measure of the signal. It can be used for SSI estimation, and LLTF, which usually used for channel state estimation and channel equalization. Of course, it can be used for channel frequency response estimation, CSI obtainment. Then, if we go further, we can consider some modern preambles which are related to 802.11n, AC, AX, and here all the legacy preamble and HT, VHT, and HE preambles can be used for RSSI estimation, like STF, which are related to STF, and some LLTF fields, LLTF and HT, VHT, HE-LTF can be used for frequency response estimation too. But here we can say that VHT, so all these non-legacy preambles and LTF from non-legacy preambles, of course, are more accurate. For example, even if legacy preamble duplicates in all, for example, 80 megahertz band, the LTF field, HE LTF field or VHT LTF fields contains more subcarriers. And since it contains more subcarriers, we get more information and our sensor become more accurate. If we consider 802.11ad and AY standards, they use three possible modulation schemes: control, single carrier PHY and OFDM PHY. And OFDM PHY is not so preferable for this technology, and control and signal carrier are more preferable. And here the fields are quite different, but anyway, we have a short training field and channel estimation field, and they can be used for channel frequency response estimation and RSSI estimation. And moreover, optional training field for beamforming can be used too. So you can use this information too if you want. Moreover, if we go to compressed beamforming action frame, of course, here we using explicit feedback, we transmit compressed beamforming reports, and here this information also can be used for sensing. So what the requirements for MAC layer? PHY layer is okay. We can use the information that's from signals to sense the environment. But there are some problems from MAC layer perspective, and here is the main, from my point of view, the main task for 802.11bf, which is under development. The first case is peer identification. If you know, now randomized MAC addresses are used, and if association are lost, you need to reassociate, and you can use the random MAC address to do this. And in this case, you can lose the identification. For example, you receive some signals from some device, and you understand that this device is the eliminator only if you save this its MAC address. But if this eliminator reassociate, so it can change its MAC address, and it can be harmful for, say, Wi-Fi sensing procedure. And another case is that identifying Wi-Fi sensing device capabilities. So it's under development now, and devices need to somehow communicate with each other and identify how it can, the frames from all the devices can be used for Wi-Fi sensing, and which fields of the frame contain some information about the Wi-Fi sensing device capabilities. Another case is sensing transmission. So how this sensing transmission occurs. As I say, there are some passive transmissions, triggered, invoked with responses, and pushed transmissions, and they are not standardized yet. And it's another task for Wi-Fi BF, 802.11bf working group to do so. And moreover, for invoked trigger transmissions, it's probably the most non-trivial task, because passive transmissions can be done even right now without any amendments. But trigger transmissions can be should be somehow standardized, because, for example, if you use some RTS-CTS schemes or NDP and EC, so, for example, if you transmit NDP and EC, you cannot fully use the all information about the spectrum, about the channel, about the environment, and you need to somehow develop new frames. For example, it can be FTM frames from 802.11az, which are related to Wi-Fi localization. But it's now it's too topic of discussion, and there are no any clear suggestions for this sensing procedure and sensing frames. This is all cases from MAC layer perspective. And for push trigger transmissions, beacons can be used, okay, but anyway, if you have some eliminator device, you need to somehow say to this device to transmit data, to transmit beacons or other sensing frames with some specific rate, and it's a case too. So here all these requirements related to the gaps actually, and as I say, to PHY there are no any needs to develop a new PHY, but anyway, it will be better if there are some mechanism to ensure the constant configuration of the radio. So, for example, if the position of the device is changed, or for example, if the number of antennas is changed, or the frequency band is changed, and so on. So, if some specific physical parameters of the transmitting or elimination signal are changed, so there are some there are some cases, there are some tasks for 802.11bf to somehow standardize this and send to Wi-Fi sensing receiver information about the change of the illuminator radio. And Mark, as I say, there are some problems in peer identification, management frame information elements need to be done, and sensing transmissions should be defined, and there should be defined the whole sensing transmission. Now we can just declare that the only one thing that which is static now and which have some concerns in 82.11bf amendment task group, working group, is the session. So if we want to make some invoked sensing, as I described further, so this procedure would be contained in several steps. The first one is discovery, where devices transmit sensing initiator and sensing responder transmits its own sensing capabilities, which are not defined yet. And then there should be some setup procedure, which are related to establishment of the sensing session, identification of sensing transmitters, which are multiple or no, and determination of the parameters of sensing transmission. The measurement procedure itself, reporting procedure if it is important, in current sensing architecture, and the determination procedure. So actually, this is the one thing that have strict concern in 82.11bf, and according to this scheme of the Wi-Fi sensing session, the further amendment will be evolved. And I guess here I can go to conclusion. And as I say, Wi-Fi sensing is a new way to use existing and future Wi-Fi network. And moreover, as I say, and I should mention again that even existing architecture and existing Wi-Fi networks can be used for Wi-Fi sensing, especially if you use monostatic mode, when you have only one device, which is transmitter and receiver and illuminator and Wi-Fi sensing receiver itself. Moreover, 82.11bf is aimed to improve Wi-Fi sensing, but it's not to aim to develop a new mechanisms to sense the environment. So there are now some specifications of special machine learning algorithms that should be used to detect your grandpa fall in your house. So, and then, as I say, 82.11bf is only in the initial phase, but many scenarios can be deployed in existing equipment. And now in 82.11bf, they develop now the sensing procedure, and they're discussing this possible scenarios which can be used for Wi-Fi sensing. And there are many work from standardization side and from research opportunities from research side to Wi-Fi sensing. And here, if you want, you will receive this presentation. And if you are interested in this topic, you can go through these papers, which are published in very good conferences or journals, which are related to Wi-Fi sensing and some approaches to detect some special signals using Wi-Fi technology. And this is all from my side. Thank you. And if you have any questions, you can ask. And moreover, I can see some questions in the chat. So thank you. Vyacheslav, may I ask to these questions in the chat? Yes?
Yeah, of course.
Great. Okay. The first question is a question from Ilya Levitsky. You have mentioned some use of cases for this technology, but many of the mentioned cases, maybe except sneeze sensing, can be addressed using other modern methods like cameras or motion detectors or smart watches. What are the advantages of using Wi-Fi sensing over these modern methods? So it's a very good question, Ilya. Actually, I think that the main advantages of Wi-Fi technology is as follows. At first, everywhere you have some Wi-Fi networks. Probably you don't want to put many cameras inside your own house or your own home, but you can use the existing Wi-Fi networks to measure the environment. And you don't need to put some special security mechanisms and some special security technologies that are used in banks to secure the money from robbers and so on. So Wi-Fi technology is cheaper, and you have already have this technology in your house. Moreover, for some special cases, Wi-Fi technology can be more preferable. For example, if you have your grandpa, your grandpa can be quite conservative person, and probably you don't want to put some smart watches on his body, because there are some 5G waves and so on, and that can be harmful for him from his point of view. And you can use Wi-Fi networks for some passive monitoring to your relatives and so on. And so that's my point of view, that Wi-Fi technology is existing. You don't need to put some more devices in your house. You don't need to put some more money. All that you need is use your existing Wi-Fi access point and or buy some new features or update some software. And moreover, as I say, some network providers can open a new business opportunity, so they can make this technology better, more accurate, and so you can decide, so why I need to buy new cameras if I have Wi-Fi access points and they work okay for me. Then next question is, why can, so it's some discussion in the chat. Why can modern Wi-Fi equipment used for sensing? Colleagues, yeah, so thank you, Artem. Which frequency bands are considered by let's do the MBF as primary for testing, development, Wi-Fi sensing? So Artem, as I said, all possible frequency bands from 2.4 till 60 gigahertz are considered as primary for Wi-Fi sensing. And moreover, this can be proved in their PAR, which they published in September 2020. So they aim to develop all directions.
Yeah, I mean, maybe there is some primary. So I understood that every band, which is currently used for Wi-Fi networking, can be used. But mainly there is some preliminary research which state that, for example, this band provide more sensing accuracy or something like that. So researchers already know what will be the better way to utilize sensing.
Okay. So in this case, I've studied some papers related to Wi-Fi sensing and all discussions in standard committee. And as far as I understand, the primary and the most suitable Wi-Fi band is 5 gigahertz here, and the most research is concentrated on this case. Moreover, 5 gigahertz can be used even for small-scale gesture recognition sometimes. So it depends on the quality of the signal and so on. And there are some research which describe this, and some specific use cases which related to some specific bands is probably breath measurements and your heart being measurements. In this case, for this application, 6 gigahertz is more preferable. But I've read some paper from Dina Katabi in MIT. So she used 5 gigahertz here, but measurements are not so accurate, I guess.
Okay, and there is the following question about prototypes. So can you just maybe list or reference to some existing prototypes which show that we have obtained the accuracy of human body movement like 90%. In 90%, we are, I mean, for positive detection. So any numbers, if you have them, it will be good to discuss.
Yeah. So actually, this information can be obtained in this paper. So I remember your question, and for this I can answer more accurately and send a specific paper and specific numbers. Now I don't remember, but here you can see this paper, which is the third one from Dina Katabi. And here, this paper about monitoring breathing and heart rate. So there are some numbers can be obtained in this paper, and I will send you it.
Okay, so I mean that they even can use 5 gigahertz to see the heartbeat rather than just moving of the people. So it's more precise measurement. So
yes, I understand.
They can do that. I think they can do a human movement, of course.
Of course.
Yeah. Thank you. I will reference to this.
Actually, if you are interested in this topic, you can relate it the whole work of Dina Katabi group. So she is publishing some papers on the Wi-Fi sensing topic from 2014, I guess. And she uses Wi-Fi access point to detect movements even in non-line of sight cases. And moreover, she built some prototypes to do so. So she had a lot of research to Wi-Fi sensing and Wi-Fi localization, and all of them, as far as I remember. So the previous researches from 2014.
Thank you, Alexey. I just wondered if there are a lot of research or not so many researchers, primary research before standard starting. So the background, actually, I see that there is some background before starting the standardization.
Yep.
And my other questions was answered during the talk. So you said that no algorithms will be standardized. Maybe you can comment how they will interact with each other. So actually, if the standard provides the framework to exchange frames, so it obtains some measurements, and this algorithm is implemented in which part of the stack. So it will be implemented at some application layer, and there should be some interfaces between the MAC layer and the application layer. So it could induce some challenges in developing interaction between layers. So can you comment something about that?
Actually now 802.11bf does not discuss any interfaces, but the previous paper which I sent in the description of this talk from Wireless Broadband Alliance. So they describe the interfaces, and they understand they concern inside the Wireless Broadband Alliance that the Wi-Fi sensing algorithms should be implemented on the application layer. And yes, there might be some interface from MAC layer and file layer to provide information about the channel state information, RSSI, and compressed beamforming metrics, compressed CSI feedback metrics. So they say that they might be some interfaces, but they do not define it now. All papers which are related to Wi-Fi sensing is based on its own interfaces, its own implementations, and most of them are used SDR, so like USRPs or Lime SDRs to obtain the physical parameters of the signal and do some stuff with it.
Okay, and is there any task or motion inside the .11bf to provide this standard interface? So if the problem exists, so maybe the standard committee will provide some solution, or it will be out of the scope of the standard. So what are the current status?
Okay, Artem. So let me check this because I hadn't concentrated on this topic yet. So I'll check it and answer.
Okay. Yeah. We can discuss offline.
Yeah, sure.
Thank you very much. I give the floor to other people. Sorry.
Artem, sorry. What kind of interface are you asking for?
I mean that the measurements and frames are working at the physical and MAC layer. So we obtain this information on PHY and MAC layer, so we have some information. And if our sensing algorithms works at the application layer, there should be some interface to MAC layer to pull this information to the application. I'm talking about application to MAC layer interface to pull information from PHY up to the application layer. So
I think this this interface will be vendor specific, because the property, so it will be done through the driver, and there won't be like so there is no need for such an interface, and such interfaces are never standardized by 82.11.
Actually, I can agree with Evgeny, because as far as I understand how 82.11 works, they do not really standardize any interfaces inside the device, but only interfaces and frames or some transmission communication procedures which occurs between the devices.
So, but this actually limits the interaction between application vendors and equipment vendors. So if only the equipment vendor can provide interface to its application to develop by the vendor applications, only device vendor can provide such application. While, for example, just usual people cannot do their own algorithms because they know they have no access to the MAC layer information. So there is a problem with maybe difficulty in implementing more applications from third-party entities. Okay, this is implementation problem, so maybe we can squeeze and okay.
Okay.
Thank you for this interesting discussion. Let us give floor to other people, maybe asking questions.
So do you have any questions?
Hello.
Yes,
I actually have a question too, and I wanted to ask it not in a written form, but just in voice. So first of all, I wanted to thank you for your wonderful presentation. Next, I was really, I agree with the discussion initiated by Artyom about the interface. And I also think that having an interface standardized will facilitate the work of application developers, but I also have concerns that it will be standardized eventually. So those are just my comments. And my actual question is, so as we can see from your current slide, there are a lot of numerous papers, and they have dates starting from 2015. So I wonder if there is any room for academic research in this field, and if so, if there is room, so what else can be studied? What else is needed from the academic community?
Okay, Ilya, thank you for a question. So at first, I put some papers which are younger, than 2015, but there are some papers even more older, from 2010, I guess, and the 2010 is, from my side, from my point of view, is the beginning of this research. And it starts because of one guy from Stanford, Daniel Halperin. So he developed a driver, or open source driver for Intel 5300 chipset. And this driver can get the information, the CSI information about the 82.11n frames. and this information can be used for some other stuff, not only for transmission purposes. And after that, many researchers started to publish some papers, and even now many papers are published using only this device, only this driver, and only this Intel TSI tool, which is developed by this guy, Daniel Halperin. And this is an open question for the research community at first. Is it all? So do we need to use some other information? So many papers uses only this TSI that I get only some specific frames and only some specific band. And this very interesting question, how to use, for example, RSSI, or how to use, for example, time domain signals, which obtained from Wi-Fi, or for example, the very open, if I can say so, it's extremely open question is how to use explicit feedback measurements to channel to sense the environment. And as far as I know, using the explicit feedback information there are no any research on this topic, and Wi-Fi community only discussed that this information can be used, but there are not any concerns how exactly it can be used. Moreover, as I can say, the Wi-Fi technology evolves, and we see that there are some new amendments like Wi-Fi 6, 802.11ax, and in a 20 megahertz band, comparing to 802.11ac, 802.11ax has 4 times higher number of OFDM subcarriers, and the accuracy increases. And it's an open question how 802.11ax can be used for Wi-Fi sensing, because now there are no any research on this topic, as far as I know. Moreover, the number of use cases increases too, and all that you need is to obtain this physical information and play with it. And I'm sure that you will find new areas to research.
Yeah, thank you for that. I also have a following question. So it's very inspiring that we still have some topics for further research, and as I have understood from your talk, the 5 features in the statement are pretty much already fixed, so we can use them. But can we use those already known features to conduct our research without any prototyping, for example, using some modeling, or if you are trying to have a valuable research, the prototyping stage is a necessity?
Actually, okay. So the all papers, the most, let's say, the most papers that I've read, which are related to this topic, are related to even prototyping, so, and making some tests. So you build some Wi-Fi prototype using USRP or another thing, and other device, and collect information and analyze it. In the Wi-Fi community, there is, and in the standard committee, there is a question how to model environment for Wi-Fi sensing. And now there are no any concerns, there are only ideas that there can be some models which are based on 802.11ad channel models, which are ray track, and the concern is that the channel model should be a ray track model, and you cannot use any some statistical models, if you know, like models from TGAN group, TGN group, TGAX groups, so they are not relevant for Wi-Fi sensing at all. And it will be great to build a very good simulation tool for Wi-Fi sensing, because it opens very huge opportunities for researchers to make large-scale experiments and play with different scenarios But now there are no the existing tool for it, and it's only under development. And from my point of view and the point of view of researchers in committee, it's a ray track model like in 811 AD.
Okay, I'm glad about that. That there is some room for researching and suggesting viable reference models for simulations. That's good news, and I'm very excited about this topic. Thank you very much.
Yeah, and one quick note that if you see the paper from Dina Katabi about the sensing and monitoring the breathing and heart rate was published in 2015, and now is 2021. If her approach is very good and very accurate, some vendors can be already implement this technology. But now we don't see any access points or some other Wi-Fi devices with this ability. So that's why there are some room for this research too.
Thank you, Aleksey, for your talk. My question is from the Wi-Fi consumer point of view. As I understand from your talk, Wi-Fi sensing needs some complicated algorithms to detect some gestures or something like that, something like machine learning or other complicated algorithms. So do you expect that the devices which will support Wi-Fi sensing, the cost of such devices will be much higher than the cost of, let's say, usual Wi-Fi devices, for example, usual Wi-Fi access point, or there will be just some small increase in price, for example, 10 or 20%. So I understand that it's quite early to discuss prices of the devices in this initial stage of 11BF, but what your expectations on this topic?
So thank you for your question, Vyacheslav. So I think that the price would not be so high and much higher than existing devices, because all that we need to Wi-Fi sensing from the hardware perspective is some interfaces that can be used for obtaining information about the channel state, the channel response, or RSSI, and so on. And then there should be an application to do so. And actually, even if we say that we need to use machine learning or something like that, the difficulty of these algorithms will be not so high comparing to existing algorithms which are already implemented in Wi-Fi, like beamforming, MU MIMO transmission, or FDMA, or if you consider modern devices like scheduling and so on. And of course, existing modules which are related to fast Fourier transmission to convert time domain signal to frequency domain signal, and encoding. So from my vision, these operations are more complicated. So this is Wi-Fi sensing is only an additional feature that will not increase vastly the price of device.
Okay, thank you.
Can I just shortly add, if this is executed on applications, one of the ways to reduce device complexity is to offload this task, for example, in the cloud. So this if this is Huawei device, you can offload in Huawei cloud, and there should be very, very complicated algorithm which analyze the data. So one of the ways to fix this problem is just sorry, just my comments on this.
Yeah, Artem, I agree with you.
Well,
but you have to pay for the cloud.
Yes.
Right. And also, I would have some concerns about sending my information about interior sensing of my interior to the cloud of some company. That opens some security issues.
Yes.
And here's why we have all these algorithms. Because, for example, if we had a lot of cameras, we were needed to send all these videos to some cloud for processing. But now, instead of this video, we send some data which does not represent all the details, and that's why it's more safety, say, than pure video. So this is the main motivation for this wireless sensing, because we do not disclose anything personal.
And what about the traditional infrared motion detectors? Why we are discussing cameras versus Wi-Fi, although we always had very simple and rather efficient infrared detectors?
So actually, as I said, it depends on the scenario that you have. And for some use cases, infrared detectors cannot be used. And moreover, from my side is the main advantage is that you don't need to implement new devices and new some radio technology inside your house. You use only Wi-Fi. And this such of centralization of the all data that gathered from your house is quite simple.
I have additional comment to this. So first of all, we have two kinds of infrared detectors. So one of them is like traditional cameras, but just they obtain image not in visible light, but in infrared. And from this point of view, there is no difference between the usual cameras and these infrared cameras, except for they can provide you some video even if it is dark in the room. Another kind of infrared sensors are quite simple, but they're rather cheap, but they have very small, very little abilities to provide you with some information. Of course, they can be used to detect some changes in the reflection, but the accuracy of these measurements are very low. And it is not enough to provide you with the full list of services that can be done with more accurate measurements. Why we use, for example, so the best case, of course, is to use millimeter wave communications for say, radio vision. But unfortunately, millimeter wave Wi-Fi is not widely used. That's why it seems that only 5 and 6 gigahertz sensing systems will be widely deployed.
Yeah, thank you.
So I think there are no any questions. So I can any more questions. So I can say thank you you all for interesting question and interesting discussions. So we will see how this technology will evolve, and I hope we will do something for that too.
Thank you, Aleksey, for your presentation. The next seminar of the will be held next week at the same time, Friday at Friday, and it will be devoted to modeling of wireless channels. So see you next week.
Goodbye.